welcome back. Here is question 2. So it reads as follows. When the polynomial expression 2x to the third minus 3x squared minus cx plus d is divided by x plus 1 and x minus 2, the same remainder of 64 is obtained. Determine the value of c and d. All right, whenever we have problems like this, the remainder theorem and the factor theorem, there is an idea here that if I have x plus 1, which was divided, it means that if I evaluate f of -1, I will get that remainder of 64. Also, if I evaluate, since x minus 2 was divided in the polynomial, if I evaluate f of +2, I will get 64. So we are gonna embark on this idea here. We're gonna evaluate f of -1 and f of +2. And from there, we will solve the problem finding c and d. All right, so let's go. All right, so we're going to be looking at f of -1, since x plus 1 was divided and got a remainder of 64. So f of x to the third minus 3x squared minus cx plus d. So I'm going to do f of -1 because x plus 1 was divided into it and give us a certain remainder. So if I do f of -1, then we're having 2, open bracket, -1 to the third minus 3, open bracket, -1 square minus c times -1 plus d. The remainder would have to be 64. So that's the principle. So what we have to do now is to carry this out, try not to make any form of error. So we're looking at -1 to the third is -1 times 2, that's -2. All right, and then -1 square would be 1 times a -3, -3. And then this will be a positive c, positive d, and this is equal to 64. So basically, what I'm looking at here, c plus d is equal to, say, 64 right there. And I'm going to be adding 5 to both sides because this is a -5, so I'll have to add 5. So basically, you see where I'm adding 5 there. So conclusion here that we are saying that one of my cases, c plus d is equal to 69. So we're going to hold this as one of the equations that we're going to be using to go forward. Now, so that's one of the equations that we're going to be using. Let's see the other equation now. Remember, I'm going to have to evaluate f of +2 because x minus 2 was divided. So we're going to evaluate f of 2. So we're looking at 2, open bracket, 2 to the third minus 3, open bracket, 2 square minus c times 2 plus d, and this should equal to 64 as stated. All right, so here goes. This is 16. 2 to the third is 8 times 2, that's 16. 2 is 4 minus 12. And then this becomes minus 2c plus d equal to 64. This becomes minus 4, positive 4, should say. And that's a positive 4 minus 2c plus d equal to 64 minus 4, because I have to take away 4 to balance out this. So minus 2c plus d is equal to 60. All right. So that is my second case. So then my second case, I'm going to put it right here. Minus 2c plus d is equal to 60. So that's my second case. So then we're going to work these out, right? So let us go together. If I have these two cases here, I could just simply subtract, because I am seeing where I have a common thing here, d. So all I'm going to do is to subtract these two equations. So let us go about subtracting them. So I'm going to have c minus 2c, and then I'll have, when I subtract d, that's gone, but definitely 69 subtract 60. So this is going to give me, remember though, that these two negative will turn into a positive. So I'm looking at 3c is equal to 9 divided by 3 divided by 3. C is equal to 3. All right, so there it is. I found one of my answer. Found out that C is equal to 3. So if C is equal to 3, now I could substitute, right? So I want to substitute 3 for C, and I want to do it in any one of these that I have. So I'm going to do it in C plus D equal to 69. Remember now, if my C is equal to 3, then I'm going to substitute right there. So 3 plus D is equal to 69. So if I subtract 3 from both sides, D is equal to 66. So we could just write that, listen, C is equal to 3, D is equal to 66. There it is, our final answer right there. That's our final answer right there for those marks. All right, so let's see what the other question is. So we're moving on to the next question. The next question says, show that the expression root of 25 over the root of 45 is the same as root 5 over 3. All right, so what we want to do is to go about representing this idea. So the root of 25 over the root of 45. If I push this further, the root of 25 is 5 over the root of 45. But I want to represent the root of 45 using a perfect square here, which is 9, because I'm seeing where 9 times 5 will give me a 45. So then I times 5, which means I could split it further and say root of 9 times the root of 5. And this, though, would have given us 5 over 3 root 5. Now, remember now we want to rationalize this. So in rationalizing this, let me write it here, 5 over 3 root 5. If we want to rationalize this, then we're going to multiply top and bottom by the root of 5. Now, when we do that, what's going to happen? On top, I'll have 5 root 5. Underneath, I'll definitely have 3 times 5. Because remember, when this root 5 multiplied by root 5, I'll just get a 5, right? Because the root 5 square Basically, we're saying root 5 square, and this is just a 5, hence this 5 right there. So we could see now that we could cancel this 5 with that 5, and we are left with 5 over root 5 over 3, which would have been that. All right. So I'm just saying you could just take your time and you walk yourself through it as we go. But definitely you are able to prove that, and that would have been your answer. All right. So here is there's things, and it says the C part. It says given that g of x is equal to 6x squared plus 12x minus 18, express g of x in the completing of the square form. The thing is, we can approach this a number of ways. All right. So let me drop the formula again. So if I know that a is equal to 6 and b is equal to 12 and c is equal to negative 18, if I have all of these coefficients here, I could just drop it in where h is actually b over 2a. So I could just find h right now, which means that h is equal to 12 over 2 times 6, which means 12 over 12. So my conclusion is 1. So I'm saying h is equal to 1. All right, that's my h value. I could find my k value right now. All right. So in going for my k value, I could say, well, k is equal to 4ac minus b squared all over 4a. So that's just one way of doing it. I'm saying that there are a number of approaches. So I'm just approaching it like this. All right, let's drop in the values that we have, right? So we're talking about having 4 times a, which is 6, times c, negative 18, minus b square, which is 12 square, all over 4 times a, and a is 6. If we push further, we're looking at getting out these values, negative 18. So 6 times 4 times negative 18. And we're looking at negative 432 minus 144. That's 12 square right there. And all right, so then, and this is over 24. So if we push further, we're looking at having minus 432 minus 144, that's 576 over 24. So this negative 576 over 24. And I believe this is going to give us a negative 24. So if I have h and k, all right, so h is equal to 1 and k is equal to negative 24, then I can definitely just represent my thing in this form where 6 goes here, which is a open bracket x, plus 1, which is the h square, and then there's a minus 24. So there it is. As I said, there are many approaches. This is just one way you could have done it. And then that would be the answer. All right, let's see the next part. So the next part is using the expression derived in CI, all right, to determine the roots. To determine the roots from this, that means we want to solve, all right? So we're going to be using this to solve our quadratic. So then we're saying that we have 6 open bracket x plus 1 square minus 24. This is equal to 0, because when you're going to be solving the quadratic, we're going to equate that to 0. So then we're taking our time to work, all right? So let us say that we want to add 24 to both sides. Then let me rewrite this. We have 6, open bracket, x plus 1 square, which is now equal to 24. Divide both sides by 6. Then you would see that we have x plus 1 all square is equal to 4, right? And then now, since I have that square, I need to get rid of that, so I'm going to take the square root of both sides. The moment I take the square root of the right side, I'm going to have to put a plus and a minus. Let me just put everything up here. So basically now we're left with x plus 1, because the square and the square root that I've canceled is now equal to plus or minus 2. So the root of 4, 2 there. So finally, I'm going to subtract 1 from both sides. So wherever we want to put it. So what I'm looking at here is x is going to equal to 2 minus 1, which is going to give me a 1. So that's one case. Or x is equal to minus 2 minus 1, which is going to give me a minus 3. So if you look, the roots are as follows, that x is equal to 1, x is equal to negative 3. So these are the roots. These are solutions are fine. All right. So there it is. We have our solutions. X is equal to 1. X is equal to negative 3. All right. So now let's look at the last question in number 2. So the last question in number 2 says, hence a sketch. So we want to sketch the graph of g of x on this grid. So it's a sketch, all right? We can just quickly do some sketch. If I drop my x and my y axis, right? So if I drop, all right. All right, so there I'm dropping my x and my y axis. So this is my y axis, yeah. This is my x axis. All right, axis of symmetry is going to be, let us say I call this negative 1 right here. So my axis is going to be at negative 1. So I'm just going to put a negative 1 here. This is where my axis of symmetry will be. And one of my roots will be at somewhere about negative 2, right? And the other root is going to be at positive 1, right there. So it's going to cross there, and it's going to cross there, all right? So that's where it's going to be. And then my y-intercept will come from the original thing. It's going to be at negative 18, okay? So it's going to be negative 18 somewhere down here. All right, so, all right. I'm going to put the negative 18 somewhere here. All right, probably here, right? So then what we'd have is this. The curve coming down is going to turn back somewhere here. So it's just a sketch, not the most beautiful thing, but that's the idea, all right? That's the idea right there. So that's my y-intercept and my x-intercept. So here I have, that's one of my x-intercept. That's my solution, my root, that's another one. And this is my y-intercept at negative 18. Let me brighten this for us, negative 18. And then this would be my, just showing my turning point right here, would be negative 1, negative 24, right? So negative 24 is somewhere here. So basically that's a sketch of that graph, all right? And that is what was expected to pick up that mark. All right, thank you for watching Dilemmas Concepts, and look out for the next video. It is coming soon.